Hi, in this video, I'm going to talk about basic configuration of OSPF v2 and v3, multi-area OSPF basic configuration. Okay, let's get started. So just reminding ourselves OSPF v2 and v3. OSPF v2 has this neighbor table, link state database, and then these best paths are offered to the IPv4 routing table. OSPFv3, traditional OSPFv3, is for IPv6. So we have it's a separate neighbor table, a separate link state database, and then these best paths are offered to the IPv6 routing table. Okay, OSPFv3 with address families actually combines both IPv4 and IPv6 neighbor tables and link state databases. Also, the configuration is a little bit different than what we're going to see here. The whole idea of address families is something that is used in BGP, OSPF, and in EIGRP. It's just basically a way to unify configuration for both IPv4 and IPv6. Okay, that's more than you needed to know right now, but let's go ahead and move forward here. All right, so here's our multi-area OSPF topology. Let's take a look at how we would configure an internal router R33 in area 1. Okay, so we router OSPF1, router ID, there's our router ID, and then the network statements. In this case, because it's an internal router, both network statements are in area 1. Okay. Similar to single area OSPF, we're just giving, say in this case, area 1 instead of area 0. Let's take a look at an area border router, R1. So again, we go into OSPF. We configure the router ID, which is best practice. And then we configure the network statements with the wildcard masks. And notice that the network statements, in this case, for the ABR, there's two different areas. We have two network statements that are area 0 and two that are in area 1, depending upon the network address and its wildcard mask for that interface. So basically, you just need to make sure that you configure the proper area for that interface. Now this router knows, by the way, this is what tells router R1, oh, I'm an area border router, okay? Because I've been enabled for OSPF on more than one area, area 0 and another area. All right, let's just take a look at another area border router, router R3, so similar. Okay, again, it knows it's an area border router because its interface, it has network statements that contain an internal area, in this case, area 51, and area 0. Okay. All right, and we have another internal router. There we go. And the internal router has all of its network statements in area 51. Okay, the ASBR. Let's take a look at the ASBR. I'm going to go a little bit beyond here. We're going to take a look at, just configuring. Here we go, router OSPF, the router ID. There's the network statements. So it has all of its interfaces in area 0. Okay. But it also has been configured with a static default route. In this case, for it's using an exit interface, best practice is actually use a next hop IP address, at least a next hop IP address. Okay, but what makes this an ASBR in our case is that we are using the default information originate command under OSPF. This is what's going to advertise the default route into the OSPF routing domain, if it exists in the routing table. Okay, so if I gave this command here without doing this static route, it'd say, oh, I've got nothing to originate. I don't know of a default route, because if I did not configure this, put a line through it, make it an X. If I didn't configure that, then it wouldn't advertise the default route, because it says, oh, I don't have one, so I guess I can't advertise it. Okay, but if I do have a default route, then it will advertise it. The reason I mention that is that there's another option of this command called the default information originate always command. This will cause the ASBR to originate. By the way, in either case, this default route is going throughout the OSPF routing domain as an external type 2 route. It will advertise this default route regardless whether or not it has one. Okay. Basically, it's just telling all the routers in the domain, don't worry about your routing table. If you have something that's not in the routing table, you just send it to me and I'll worry about it. Okay. Now, of course, if you use this always command and you do not have a default route, then in the routing table, okay, in its routing table, that destination IP address does not exist in one of the networks in its routing table, it will actually drop the packet, put in the bit bucket. It won't forward it because it won't have a default route. Okay, but so it's basically just saying, don't you send it to me, I'll decide whether or not to send it out of our routing domain. That's the always option. Okay, so here we have on router R2, our ASBR, we can see all those inner area type routes. Those are the ones learned via LSA type 3s, right? Okay. LSAs from another area. Those are the ones that remember, let me just kind of remind us, there are LSA, I'll just put a 1 here, an L1 in this area. That's what these were. And then the ABR generated them as type 3s, LSA type 3s. And that's why, in this case, the ASBR sees it as an inter-area route because it learned them via LSA 3s. And just another reminder, remember that the good thing is if this network here goes down, let's take this one here goes down, all the routers in this area have to rerun the SPF algorithm, come up with a new tree and off, and off of the best paths to the routing table. What do these other routers like the ASBR do? They just go, oh, I just remove it from my routing table. That's all I need to do. Remove it from my link state database, remove it from my routing table. Okay, that's the advantage of an LSA 3. Okay. Okay, OSPFv3. Okay, so let's take a look at configuring router R1. I have a default route pointing to the ISP, default static route. We have to use the IPv6 unicast routing command. Okay, we must do that to be able to use this command, IPv6 router OSPF2. Okay. Okay, there's our process ID, and similar to OSPFv2, this does not have to be the same on all the routers. Best practice, it should be. Okay, router ID, okay, and we must have a router ID in this case if we do not have any IPv4 addresses. Okay. I've done the passive interface. There's our default information originate command. That's going to propagate the default route into our routing domain. Okay, this is how I configure it. All right, on the interface, IPv6 OSPF2 area 0. And do that for both of our interfaces. So this is no different than what we saw for OSPFv3 single area OSPF. Let's take a look at our ABR, R2. Again, IPv6 unicast routing. Okay, same process ID, doesn't have to be. Okay, router ID. Okay, here's the difference. So on our serial 000 interface, we enable that for area 0 OSPF. And on our serial 001 interface, we enable that for area 51 OSPF. And that's how this router knows it's an ABR. Router R3, which is an internal router in area 51. Similar commands, but notice that on the interface, we just enable both interfaces for area 51. Okay, so if I did show IPv6 route on R1, this tells me it's an OSPF inter-area route, OI. Okay, so both those networks that it sees, I think there we go. Both those two networks there are OSPF inter-area routes in another area, learned via LSA3s. Okay, so on R3, remember we're propagating that default route, and there it is right there. Whoops. So there it is right there. Again, so in this case here, it's also an external route. All right. All right. Hopes this made sense a little bit on configuring multi-area OSPF. The basics, just the basics for OSPF v2 and v3, but it's pretty straightforward.